Name is Blaise Pascal. I am a French philosopher born in Avignon, France, 19 June 1623, and I am famous for many of my mathematical, philosophical, and studies, especially the ones of fluids. And today I will show you my triangle for Pascal's triangle.
Pascal triangle is a concept used to calculate how are binomial elevated to any power form. To build a triangle, start with 1 at the top, then continue placing numbers below it in a triangle pattern. Each number is the two numbers above it added together, except for the edges, which are all 1. How do the coefficients of the expanded binomial relate to the number in Pascal triangles? You multiply the variable by the number inside the triangle. For example, 1, 3, 3, 1 in a binomial cube. You will multiply the first coefficient by 1, the second by 3, the third by 3, and the fourth times 1. Hi class, I'm your new teacher, Isaac Newton. I'm gonna tell you something about me. I was born in Lincolnshire, England in 1642. And I'm a physicist and mathematician. I'm a real good scientist, and I have promoted the three basic laws of physics: the law of Newton and the law of motion.
Theorem is a quick way of expanding a binomial expression that has been realized to some large power. For instance, the expression 3x minus 2 to the power of 6, we can pull the binomial 3x minus 2 and the power 10 into the formula to get the expanded multiplying out from and combine it with the formula for combination. We find out that in 10 combination, 7 is equal to 120.
The binomial theorem relates to the concept of combinations in the way that to find the coefficients by the binomial theorem and also of the Pascal's triangle, we can apply a formula that is very similar to the one used in combinations. Also, by applying factorials to the first and second terms exponents, the first descending and the second ascending.
We have different rules for the binomials elevated to a certain exponent. For example, when it's 0, the result will always be 1, no matter which number it is. And another rule is that the number of terms in the result will always be the number of the exponent plus 1. For example, when you elevate a binomial to the square, you get 3 terms in the result. Also, another rule is that in the accommodation, you have the inclinated and declinated exponents. For example, in the binomial elevated to the square, in the term a, you start with a to the square, then a, then nothing. And in b, you start with nothing, then b squared.
Use the binomial theorem to expand the expression 2x plus e to the square at the power of 6. The procedure we used was to take each number from the Pascal's triangle from the corresponding exponent and begin multiplying it with the initial coefficient and power it up to the corresponding exponent.
Terms in the expansion of x to the 1/2 plus y to the 10th power. The procedure we used was to take each number from the Pascal's triangle from the corresponding exponent and begin multiplying it with the initial coefficient and powering up to its corresponding exponent. This time a special law has to be applied because x is elevated to the 1/2, and that means that any result given to x must be used as a square root. And then we get as a result
we find the seventh coefficient from the Pascal pyramid, and we know that from the past activities that the result is going to be
fifth and 12th term of 2x plus y to the 3/4 to the 13th. This is the challenge that we propose as a team, and in this way, students can use all the knowledge gained in the report and solve a challenging problem without being too complicated.
So, as a conclusion, these types of formula come in handy when trying to solve extremely large exponents for a binomial, and in some cases might be used to prove the derivative formulas and combination problems.